Hello guys, this is CodeNCode and this is fourth lecture of Java design pattern. In this lecture, we are going to cover factory method pattern, which is again one of the many creational patterns. Right? So let's get started with the lecture. Let's see why do we need it, how does it help, and the implementation of everything. Right? So let's get started. So what is factory method pattern? So it provides an interface for creating objects in superclass, but allows subclasses to alter the type of object that will be created. Let's understand this. So first of all, you can use a factory method pattern where you have a superclass and it has multiple implementation of it or multiple subclasses of it, and you don't know at the compile time what type of object you'll actually need, of which class you'll actually need. Right? It is given rather to you at runtime, like user input or reading from database. Right? So in these kind of situation, you can use factory method pattern, which at runtimes you can decide which object to instantiate, right? And about this statement, let's have a look at it. So for factory method pattern, we have a superclass, right? And we have multiple instances, not instances, subclasses of it. So what do? In superclass, you actually declare the factory method, a method that is used to create an object, right? That is called factory method. So what you do, you can have either an interface or an abstract class in which you can define the factory method. Now, each time a new subclass you add, it has to override this method and define how object of its class is going to be created. See? So you're providing a method into the superclass and subclasses will override it to instantiate or create their object, right? And of course, here subclasses implement the factory method as explained earlier, and then client uses the factory method to get the object. Now, client is not going to create the object itself using the new operator, right? If I'm using certain library and I need certain object from that library, what do? New XYZ class, right? But that is not a good design, right? So a better design, why is that? So let's understand that with an example. So a basic example would be, let's say that object that I'm talking about, you have imported certain libraries, you are using that, and from that you are using, let's say, class C, right? And you need that class C at 50 different places in your code. So you have created an object of class C in 50 different places using new operator. Let's say the library decides that the way it creates an object is going to change. For example, in its parameter, while creating an object using a new operator, it adds one more field. So 50 places where you have actually use a new operator to create the object of the class, 50 places you have to go ahead and pass the newly added field, right? So any changes in the client breaks you in the library breaks your code, which should not happen. If the responsibility of creating a new object was with the client, its library itself, in the client, in my code, I could have just directly called the method to get the object. So if any changes are made into the library, won't affect my code. Right? I'll explain that with an example. Right? So that is very important. So what it does, it delegates the process of creating a new object back to the classes itself. It should not be your responsibility as a client to create a new object, right? So it supports basically basically this decouples your code from creating a new object, and it makes your code extensible actually, right? So yeah, so this is the factory pattern and why it is used. So what are the benefits of it or applications? So when the exact class of object to be created is unknown at compile time, as I explained earlier, you don't know at the compile time which object you need. At runtime, you have to decide. For example, let's say we have a compiler abstract class, and it has multiple concrete classes or subclasses. Let's say Java compiler, C++ compiler, Python compiler. At runtime, you need the compilers. You don't know what compiler you need at this moment, right? You are reading a user input and then you need C++ compiler, so you want that, right? So if the object the class of the object that you need is not known at the compile time, this will help you, right? Factory method. And factory method ensures that the actual instantiation logic is encapsulated. That means I am as a client getting the object created by the library itself. I don't know how that is being created, right? So it promotes encapsulation, right? So it basically hides the detail of instantiation of the object from the client that uses it, right? And of course promotes loose coupling. How? As your code depends only on the interface. Basically, inside your code, you can define compiler C is equals to get Java compiler or get Python compiler or get XYZ compiler. Your code doesn't have to depend on the concrete classes or the implementations of that, right? So it promotes loose coupling. Yeah, so these are the benefits of factory method pattern, right? Now let's talk about the implementation. Again, we are going to implement it using two different ways, one of which is one factory class for all subclasses and another one single factory class for each subclasses. So I'll explain this in a moment when I show you the code how we are going to implement it. What you'll do, let me show you the code itself, and then while implementing I'll explain this one easy to implement, but as your code grows, hard to handle this, right? Hard to maintain this, and it becomes bulky. I'll explain that. And this one is preferred when your code may get many subclasses. All right. So let's have a look at the factory method pattern and then understand the difference between these two. And both of these implementation we are going to do right in Java, of course. So let's get started with the implementation. Right, so as you can see, I have two packages, preferred and simple. So let's start with the simple one, which is basically one factory class for each subclasses. I'll explain that in a moment. In my client, I only have my main function that uses this library, and this is the library that provides multiple compilers, right? So I have an abstract class compiler which defines a function compile. So you send a code to it and it compiles and returns the result, whatever it is, right? And then I've defined an enum for multiple compiler type, Java, C++, Python, not as important. And I have also defined three different subclasses of compiler. So CPP compiler, extends compiler, and of course it has to override the compile method, right? And as you can see, from the compilers, I'm only returning a single string that tells you which compiler was used and compilation successful. CPP compiler, Java compiler, Python compiler, all of which extends compiler, right? So there are three different compilers at our disposal that we can use. Now, as we discussed, the factory method pattern says that the process of instantiating the object should be delegated back to the library itself or the class itself. So here we have a single factory class, which is responsible for creating objects. So here you can see it has a static method get compiler where you can provide the compiler type and it will return object of that compiler, right? So if it is the type is CPP, return CPP compiler, Java, return Java compiler, Python, return Python compiler. If any unknown value is passed, of course throwing an exception, right? So this is my library, very neat and clean, and we have delegated the process of creating new object to this compiler factory. Let's say as of now we are instantiating the compilers without any fields, right? And in your code, while creating a compiler, if you were creating compiler in your code yourself using new operator, let's say at 50 places you were instantiating this CPP compiler. At 50 places you are doing this CPP compiler is equals to new CPP compiler. If you're doing this at 50 places in your code, and later this library decides that while instantiating the CPP compiler, right, public CPP compiler, you also need uh, a string. I'm not going into detail what it is, right? Now there is an issue. Now your code breaks. You will get an error in your code. So something changes in the library, your code fails because you decided to use new operator to create object. This is tight coupling. It shouldn't happen, and that is why the factory method pattern promotes loose coupling. So it is no longer your responsibility to create object, but of factory. So the library, the guy who's changing the library, can simply pass certain string and everything fine. No matter here, since you are not using, of course, new operator, you can directly get CPP compiler. Nothing you have to do to accommodate those changes. You don't have to change anything, right? The library takes care of it. So let me just go ahead and change it. I don't want this constructor. Yeah. So this is one of the methods you can implement factory method. So you have an abstract class and multiple instances of it, multiple subclasses of it. You can define a factory class inside of which you are instantiating the object, right? And when you need it in the library, sorry, in the client, what you can do, you can simply create a compiler is equals to factory dot get compiler. What type of compiler you need, just pass the type and you'll get the compiler, right? As simple as that. And from compiler, I can just say compiler dot compile. Let's say instead of passing code, I'm passing C only, right? So if I run this code, it will say, hey, compile successfully using CPP compiler, right? My bad. I have a compiler. It compiles. Yeah, it returns a string. I need to print that. Control X. Uh, S out, I guess. Yeah. So if I run this now, so a shortcut, you write S out and it just it writes itself system.out.println. So right, compiled successfully using a C++ compiler. Now important thing here. Now your code doesn't depend on the concrete classes. My code doesn't depend on CPP classes. I'm able to use the code as well, right? It doesn't import CPP class, right? But if you were using a new operator to do it, what you will do? You'll do compiler C is equals to new CPP compiler. As soon as you do that, CPP compiler is imported here, right? Right. So when you're using a factory method pattern, you don't need to depend on the concrete classes. It makes your code extensible. As you can see, if I want Java compile, I'll do this simply. I don't have to change anything. If I run it, yeah, I have Java compiler because my code depends on the abstract class, not its implementation, basically subclasses, right? So it promotes loose coupling. So yeah, this is how we can implement whatever the factory method pattern, right? Using single factory class, which is responsible for creating all of the objects. Issue with this is not the very preferred way. First of all, when you should use it, if the number of subclasses are going to remain very less, like 4 or 5, that's it. It is going to increase. If it is going to increase, this becomes an issue. It becomes very bulky class, right? And also, the other issue with this is that you might have studied solid principle, right? So it violates the open close principle. Open for extension, close for modification. Once you write the code, your class should not change, right? That is not the case here. If I add a new compiler, right? Uh, let's say Rust compiler, PHP compiler, I have to add that here also. So it violates open close principle. So these are the two issues with it. Now, a better way to implement it is using, yeah, uh, yeah, this is the better way. And the way to do it is define a factory for each implementation of the subclass. All right, let me show you that also. Let's try to understand this. The preferred method is to have a single factory for each subclass, right? So let's say I have notification, right? So I have an interface notification which has a function notify user, right? So I have email notification which implements notification. I have push notification and SMS notification which all override the function notify user, and each just print a simple message, right? Sending SMS notification, push notification, or email notification. These are the classes. Again, multiple subclasses. Now, a preferred way is not to have a single factory class, but multiple factory classes for each subclasses, right? So now I have notification factory, an interface, right? And what it does create notification. So this is the interface which provides the method to create the object, right? Create notification. Now, any implementation of the factory can implement it and return its object. So I have an email notification factory. It implements notification factory, right? And it creates an object of email class. Similarly, for push notification, it implements notification factory and implements create notification method, returns push notification class and SMS notification class. As you can see, we have different factory classes for different subclasses of that interface, right? Now, as I was saying, that it supports first open close principle, right? So whatever you have defined, when you are adding a new notification, you don't have to change any of these classes. All you have to do, create a new notification and add a new factory to it, right? So it supports open close principle. And also, if you are adding multiple new notifications, there is no single place where everything is kept at a single place, and that class won't become bulky, unlike the factory class that we have seen just now, right? So once you have this in your client, you can actually get those things. For example, you are creating a notification, and let's say you want SMS notification. So you just create an SMS notification factory and call the create notification function. This is the one that creates the object and return it. So it will create an SMS notification object and return it. So you have notification. When you call the notify user, it will print the message that whatever, SMS notification, here it is. It will print sending SMS notifications. If I go back here, run it, yeah, sending SMS notification. So you see, the second one is just as simple as the first one, right? But the second implementation is a bit better because it supports open close principle, and it doesn't have a single place where all of the instantiation is happening, and hence your code won't become bulky, right? So if I show you here, what are the differences between the two? So for one factory for all subclasses, the first approach, we have centralized object creation in one place. But that comes with an issue that it will become bulky. Now, reduces the code duplication by handling all related object, of course, and easier maintenance as all logic is in a single factory. So if you it is easy to maintain because if you are going to add a new notification or adding a new compiler, just create that, and its instantiation logic you just add into the single factory. So you don't have to juggle around and find where you need to make changes. You already know there is a single place when I need to make changes. You go there and do that. So it is easy to maintain, right? It won't take much time. Now, the benefits of creating multiple factories for multiple subclasses is that each factory is responsible for only one type of object, making it more modular, right? And easier to extend because all you have to do is just create a new object and create a new factory, right? So this is easier to extend, right? And clearly it supports a single responsibility principle because each class have a single responsibility. That means each factory has a responsibility of creating only a single object, which was not true here. So this comes from solid principle, S of solid, SRP, single responsibility principle, and also open close principle, right? So from this basically promotes a single responsibility principle and open close principle. So even if the instantiation of certain object becomes complex, you can handle it in a single class because it has only a single factory, right? So yeah, these are the differences between the two. Which one you are going to use? As I said again, if you know that you are not going to add a lot of subclasses, probably going with this one is very easy because the second approach comes with a lot of boilerplate code, right? So it's up to you. It's up to your use case. If there are not so many subclasses, go with the first approach, easy to maintain and easier to handle, right? While the second one is better when you know that in future there may be multiple and a lot of subclasses. Go with the second one. it's and sorry, if you have multiple classes, your single class won't become bulky like in this case because of single factory, right? And working and modifying things in the second approach is much easier, because if you are making any changes in one class, its factory only needs to be updated, right? So yeah, these are the differences between the two approach that we discussed, and this is how you implement using two different approaches the factory method pattern, right? So this is it for this lecture. Thank you guys for watching, and till the next video drops, keep coding. Thank you.